Welcome to Physics World Online College, where the knowledge of physics is espoused to you for you to excel in your exams. In our class of today, we will be looking at conversion of a galvanometer or milliammeter to a voltmeter. This is a continuation of the last topic where we converted a galvanometer or milliammeter into an ammeter. So in today's class, we will focus on knowing what is a voltmeter and how to achieve that conversion of a galvanometer into a voltmeter. Please remember to share this class video in your various social media handles. Let your friends in other school know what is happening in this channel. Let's continue with our class for the day. First of all, let's know what is a voltmeter and then how we can arrive at the formula for converting a galvanometer into a voltmeter. So, a voltmeter is an instrument used for measuring potential difference, PD, or EMF. Now, the voltmeter is a high resistance device. In fact, an idealized voltmeter has very large resistance or infinite resistance. And this voltmeter is normally connected in parallel across the component whose potential difference is to be what? Determined, is to be measured. Now, there's something I want to clarify. A voltmeter is not the same as a voltmeter. Let me say that again. A voltmeter is different from a voltmeter. I just defined a voltmeter. What then is a voltmeter? A voltmeter is a vessel containing electrolyte and electrode that is used during electrolysis. In fact, electrolysis takes place inside a voltmeter, so it is not the same as what? A voltmeter. Let's take that down. A voltmeter is an instrument used in measuring potential difference, PD, or EMF. I said a voltmeter is a high resistance device. A high resistance device. And it is always connected in parallel to the component whose potential difference, PD, is to be measured. I said, in fact, an idealized, that is an ID voltmeter, an idealized voltmeter has a very large or infinite resistance. Good. I also said that a voltmeter is different from a voltmeter. A voltmeter is different from A voltmeter. And what is a voltmeter? A voltmeter is a vessel containing electrolyte and the electrodes used for electrolysis. And I said electrolysis takes place in the voltmeter. Now, how do we convert a galvanometer into a voltmeter? Mind you, a galvanometer, like I said in last class, measures very small value of current. Another instrument that does that is a milliammeter or a microammeter. So this question or topic could have been about converting a microammeter into a voltmeter. It is possible. It's the same principle you will what? Apply. Let's continue. To convert a galvanometer or milliammeter into a voltmeter, what we have to do is to connect a high resistance called multiplier in series to the galvanometer. I said a galvanometer or milliammeter can be converted into a voltmeter by connecting a high resistance called multiplier in series to the galvanometer. Take note of how it is connected. The multiplier is a high resistance connected in series, not in parallel. Very important. So how that connection is done is always asked in the exams. So you should take note of it. Now, let's try and obtain the formula. How do we determine the value of that high resistance? How do we determine that the value of that multiplier that we have to connect to the galvanometer so that it can become what? A voltmeter. Let's consider this hypothetical example. Let's have the galvanometer whose internal resistance is ROG, and the current flowing through this galvanometer, let it be IG. We are going to connect, I said, a high resistance called multiplier in series to the galvanometer. So let me call the resistance of the multiplier ROM, the resistance we want to determine. Now, the current that will flow through the multiplier, let's call it IM. Now, once you have current flowing through where a resistance exists, there will be a voltage drop across that what? Component. So which means the current multiplied by this resistance will give us a voltage drop we will call VG. That is a voltage drop across the galvanometer. So this VG is IG ROG according to Ohm's law. Likewise, we will have a voltage drop across the multiplier. Let's call it Vm. Also, this Vm is equal to what? Im Rom, according to Ohm's law. Now, we want to convert this galvanometer into a voltmeter. Mind you, this voltage of the galvanometer, this PD of the galvanometer is a very small value. But now we want to pass a bigger value across this galvanometer. So let that value, let's represent it with V. So this V is bigger in value than the voltage of the what? Galvanometer, which means in the ordinary, if you allow this voltage to go through this galvanometer, it will burn. If you allow this voltage to pass through this galvanometer unprotected, that is, without the connection of this high resistance called multiplier, if you pass this value of voltage, which is substantial, across this galvanometer, it will damage it, it will kill it. So by connecting this multiplier in series to the galvanometer, you are protecting this galvanometer from excess damage due to voltage. So remember, we want to determine the value of this resistance that we need to convert this galvanometer to be able to measure a very large voltage. Now, let's derive the formula. So let's say that the current that will come from this source, let's call it I. Now, you will see this is a series connection. So since the connection is a series connection, one, the current is the same. The same current will flow through everything. So this current, and this current, they are the same because it is a series connection. Two, the total voltage V is equals to the sum of the voltages Vg and what? Vm. That is according to Kirchhoff's voltage law. So let's put that down. I say since the circuit is connected in series, then Ig, the current flowing through the galvanometer, sometimes they will tell you it is a full scale deflection current through the galvanometer, is the same thing as Im, the current going through the multiplier. Both of them, they are equal to what? I. So in questions that concerns converting galvanometer to voltmeter, only one current is given. That current is the same for all the device, all the components in that circuit. So take note of it. So in the final derivation, in the final formula, I can use Ig, I can use Im, I can use I. The choice is mine. Then I said this voltage is equal to Vg plus Vm according to Kirchhoff's voltage law, which means I can substitute, I can make Vm the subject of formula. If I make Vm the subject of formula, I have that Vm is equals to V minus what? Vg. What does that mean? In place of Vm, I can put what? Im, since I said Vm is equals to Im. Likewise, in place of Vg, I can put what? Ig, since I have said that Vg is equals to I arrow, Ig arrow G. Let's take that. I said, but Vm is equals to Im arrow M, which I can also write because Im is equals to I. I can say it is what? I arrow M. If I want, I can. Likewise, Vg is equals to Ig arrow G. In place of Ig, I can put I. So I arrow G. So if I substitute it into this formula, it means I'm having that Vg is equals to V minus Vm is equals to V minus Vg. So in place of Vm, let me put I arrow M is equals to V minus Vg. If I make arrow M the subject of formula, I will have Vg, I will have V minus Vg over what? I. Now, I can also write this to be, or arrow M is equals to V minus, in place of Vg, I can put I arrow G I. This is another way of representing it. Or I can say arrow M is equal to V minus, in place of Vg, I can put Ig arrow G over Ig. I told you all the current, they are the same because this connection is a series connection. So how do you know a series connection? The same current flow through them. So I can also write it as arrow M is equal to V minus Im arrow G over Im in terms of M. So the choice is yours. Although more applicable is this. So you have to take this note of this and also this in terms of the voltage. So remember, once an equation has been obtained, you can be asked to look for anything. Is that clear? So we are going to solve the example. We solve example that we have there. So we have a question that says that a galvanometer of resistance 2 ohm gives a full-scale deflection when you have a current of 50 milliamp flowing through it. How will you convert it into a voltmeter capable of measuring up to 10 volts? Now, let's apply that and solve this question. Now, we are given a solution to example. We are given the resistance, that's the internal resistance of the galvanometer. Arrow G is given as 2 ohm. And then we are given the full scale deflection of current through the galvanometer as what? 50 milliamp. That is the same thing as Ig. Like I've said, is the same thing as I. Is the same thing as Im. All of them are the same, given as 50 milliamp. You must remove that milli sign by multiplying. This becomes 50 times 10 raised to the power of minus 3 amp. 50 times 10 raised to the power of minus 3 amp is the same thing as 0.05 ampere. So that is the current of the galvanometer. So we are saying the current that is flowing, Ig, is 0.05 amp. Now, arrow G is 2 ohm, which means the voltage through the galvanometer, Ig arrow G, is 2 times 0.05. That will give us 0.1 volt. So you can see that the value that the voltage across the galvanometer is very small, 0.1 volts. But here we want to what? Pass a voltage of what? 10 volts through this galvanometer. So we are given that V is what? 10 volts. If you pass 10 volts through this galvanometer unprotected, it will damage it, like I said. So to protect it, we are connecting this shunt. We are connecting this multiplier in series to the galvanometer to protect it. Now, how do we now get ROM, which is what we need to get? So V, this V now is what? This is 10 volt. Now, we use any of the formula. I can use any of the formula. Let me quote this one. So we are looking for ROM. So I say from ROM equals V minus IG ROG divided by IG. So I have decided to solve using IG. I could have used this, I could have used this, I could have used any one that I choose. So now let's substitute our value. This means that ROM is equal to our V is 10 minus our IG, like I said, is 0.05, and our ROG is 2 divided by our IG 0.05. What does that mean? 2 times 0.05 will give us 0.1. So 10 minus 0.1 will give us 9.9. So we have that ROM is equal to 10 minus 0.1 divided by 0.05. That means ROM is equals to 9.9 divided by 0.05. When you divide 9.9 by 0.05, you will get 198 ohm. You see that this value of resistance is very high. How will you connect it? Like I said in the first class, always attach how this resistance is connected. That in itself has mark in a theory exam or in a exam for the OBJ. That is a question on its own. How it is connected. Is it in series or in parallel? They always want to test students on that. So you must say how it is connected. So 1.198 ohm connected in series. Connected in series. So this resistance that is very high connected in series to the galvanometer such that it can measure a higher value of voltage is called what? Multiplier. So I said this resistance, this resistor of high resistance connected in series. So the galvanometer or milliammeter is called a multiplier. Now, the issue is, what is it actually multiplying? And then, what other advantages or implication is this knowledge we are trying to establish? One, you will see that the internal resistance of the galvanometer is very small, 2 ohm, but you need actually a total of what? 200 ohm to withstand this what? 10 volts. Let me take that again. The internal resistance of the galvanometer is 2 ohm, but the total resistance you need to withstand this galvanometer, this voltage of 10 volts, is what? 200. That is 198 plus what? 200. So what happened? By adding this multiplier of this with this value 198, you have boosted, you have increased the internal resistance of this what? Circuit. Hence, it is able to withstand higher what? Voltage. So this multiplier is a booster of the internal resistance of the circuit. So I want you to take note. I said, note that the multiplier is a booster of the internal resistance of the circuit. So it multiplies the internal resistance to now bring it up to capacity to withstand higher what value of voltage. Good and fine. Another point that you need to know is, like I said in the last class, in the industry or at home, of what importance is this learning to us? Actually, converting galvanometer to a voltmeter is all about voltage protection. That is, protecting an expensive device, protecting an expensive machine against over voltage, against excess voltage, against voltage surge. So if you don't want an expensive device to get bad due to excess voltage, look for what? A high resistance what? Device, and connect in series to that expensive machine or instrument, thereby protecting this instrument or machine from excess voltage. What am I saying? You will discover that you connect adapter to your television. That adapter is serving as a multiplier. Yes, that's what I'm saying. So the adapter serves as a multiplier, as a protector to your what? Television. That is exactly what I'm talking about. That's one. Then another point you need to take note of is converting a galvanometer into a voltmeter is all about increasing the voltage rating, increasing the voltage range of an instrument. What am I saying? If you see that the voltage of the galvanometer ordinarily is from 0 to 0.1 volts, but by connecting a multiplier of value 198 ohm in series to this galvanometer, I have been able to what? Raise its rating to what? 0 to 10 volt. So it's about raising the what? Voltage rating of an instrument. Good and fine. So I have assignment 1 and 2 for you to attempt. Please solve it and send your answer to me. I will reply you accordingly. Thanks for your time.